still more, solving quadratic equations. Recall the zero factor property. We've been using that to solve quadratic equations. The zero factor property says that if a product of two things is zero, then one of those factors must be zero. So, if you have something times 0 equals 0, or something 0 times something equals 0. That's the only way you're going to get a product of 0. So when we have an equation that's written as something times something equals 0, then we know either this is 0 or this is 0. And we use that to solve equations. The steps we go through to use the zero factor property is the first thing is we set our equation equal to 0. Then we factor the polynomial side. So we'll have a product of two things equaling 0. So we use our zero factor property to set it equal to 0, and then we solve each equation. And that will give us the solutions. So here we have two equations that we can solve by factoring. X squared minus 49 is already set equal to 0. So what we need to do is factor the x squared minus 49. X squared minus 49 is a difference of squares. So remember that that would factor into x plus 7 times x minus 7. You'll take whatever you square to get your x squared and put it in the first part of each parentheses, and whatever you square to get the 49 and put it in the second part of each parentheses. You'll have addition in one and subtraction in the other. So we factored our difference of squares. Now we use our zero factor property to set each factor equal to 0. X plus 7 equals 0, or x minus 7 equals 0. To solve this equation, we have to subtract 7 from both sides. So x would equal negative 7. And to solve this equation, we have to add 7 to both sides. So we get x equals positive 7. So each of these is a solution to x squared minus 49 equals 0. Now my second equation is not set equal to 0. So the first thing we have to do is get it equal to 0, and we do that by subtracting 16 from both sides. So this will give us 25m squared minus 16 equals 0. Once I have it set equal to 0, I try to factor the polynomial side of it. Here again, I have a difference of squares. 25m squared is a perfect square, and 16 is a perfect square. So I'm going to factor that. So what I need in the first part of each parentheses is going to be a 5m, because 5m times 5m gives me the 25m squared. And I'll have a plus 4 in one of them and a minus 4 in the other one. So now I have a product of two things equaling 0. To solve it, I set each factor equal to 0. 5m plus 4 equals 0, or 5m minus 4 equals 0. I solve 5m plus 4 equals 0 by subtracting 4 from both sides. That'll give me 5m equals negative 4. Then I divide by 5 to get m equals negative 4/5. The other equation, to solve it, I have to add 4 to both sides. That gives me 5m equals 4. Then I divide by 5 to get m equals 4/5. So there's my two solutions for this equation. My next equation is x squared minus 3x equals negative 2. Same process. I want to set it equal to 0, which means I need to move my 2 over. So I have to add 2 to both sides of my equation. So this is x squared minus 3x plus 2 equals 0. Now I want to factor my polynomial. Here, this is not a difference of squares. This is a trinomial. So I factor this by putting the x in the first part of each parentheses. Then I want to look for numbers that multiply together to give me 2 and add together to give me the negative 3. So that's going to be a negative 2 and a negative 1. Because negative 2 times negative 1 gives me positive 2, and negative 2 plus negative 1 gives me negative 3 in the middle. So I have x minus 2 times x minus 1 equals 0. Now I use my zero factor property to set each factor equal to 0. So for x minus 2 equals 0, I add 2 to both sides to get x equals 2. And for x minus 1 equals 0, I add 1 to both sides to get x equal 1. So I have x equal 1 and x equal 2. Let's look at one more of these using this method. Here again, my equation is not set equal to 0. So to set it equal to 0, I have to subtract my 20m from both sides. That's going to give me 25m squared minus 20m equals 0. Well, this is not a difference of squares. It's also not a trinomial. The only thing I can do to factor this is pull out the common factor. The greatest common factor here would be 5m. So in the parentheses, I put what I have to multiply my 5m by to get 25m squared. That would be a 5m. Then what I have to multiply 5m by to get my 20m. So that would be 4. Because of the subtraction, I put minus 4 there. I still have a product of two things equaling 0. So I set each of my factors equal to 0. 5m equals 0, and 5m minus 4 equals 0. To solve 5m equals 0, I divide by 5. To solve 5m minus 4 equals 0, I add the 4 to both sides, and then divide by 5. So I get 4/5 and 0. Now I want to show you one more process you can use for the same equations we just solved. X squared minus 49 we solved earlier by factoring. But anytime you have an equation like this where you're missing what we would call that middle term, you have your x squared term and you have your constant term, you can solve it by using the square root property. The square root property says to get x squared by itself. So to do that, that's your first step. We would add 49 to both sides. That would give us x squared equals 49. Then we're going to take the positive and the negative square root. And we're going to do that on both sides of our equation. So I'm going to take the square root on each side. So that would give me x equals the positive or negative square root of 49. But what is the square root of 49? 7. So I get an answer of positive 7 and negative 7. This is the same solution that I got using factoring. Now, this means I have a positive 7 for an answer and a negative 7. This plus or minus symbol is just a shorthand way to write it. This second equation we also solved earlier, but we can use the square root property on this one also to get my x squared, or in this case m squared by itself. My first step here would be to divide by 25. That would give me m squared equals 16 over 25. Then I'm going to take my square roots on both sides, and I've got to remember the positive and the negative square root. So this is the positive or the negative square root of 16 over 25. But what's nice about 16 over 25 is both of those are perfect squares. The square root of 16 is 4, and the square root of 25 is 5. So here I get the positive 4/5 and the negative 4/5. This one, the same process works. It's not just an x that's squared, it's an x plus 5. But I can still take my square roots on both sides. When I take the square root of something squared, it's just going to give me whatever's being squared under there. So that's the x plus 5 part. But now over here I'm going to have the positive or the negative square root of 36. Now we know the square root of 36 is 6. So what I really have here is one equation that says x plus 5 equals 6, and one equation that says x plus 5 equals negative 6. Now I've got to solve each of these equations. Subtract the 5 for the first one to get x equals 1. I subtract the 5 for the second equation, and I get x equals negative 11. So my solutions here are 1 and negative 11.